So the quadratic model is hopefully going to be a little bit more accurate. It's still not going to be quite the right shape for just one quadratic. So what we'll do is we'll split our data, the first half where the death rate is increasing, and then a second parabola where the death rate is decreasing. So what we're going to have to do is draw two quadratics, and because your wrist moves like that, it's easier to turn the page upside down. So if I've got one quadratic that looks a little bit like that, and then another quadratic which is going in the other direction, so that will come down about there. So the two lines are going to look like they're going to meet round about this bit here. The smallest value here is this one, and the biggest one here is this one. So looking at the first parabola, so if we look at curve 1, we know that the turning point, so the vertex, is at 0.53, and we know that another point that's on the line is this one, when we're going to get these two to cross over at the point which is 35 and 4.35. So that's our crossing point where the two lines cross, and this is our vertex. So we need to use the completed square form. So that is y equals a brackets x minus p all squared plus q, where p and q are the coordinates of the vertex. So we have y equals a x minus nothing plus 53. So in order to find out the full equation, we're going to need to substitute this second point in. So we end up with 435, which is our y value, is a brackets 35 take away 0 squared plus 53. So to work this out, we'll take 53 off both sides. So 435, take the 53 off both sides, gives us 382, and a is multiplied by 35 squared. So if we divide both sides by that, then a is going to be 382 divided by 1225. So a is 0.312 to three significant figures. So that is 0.312. So if we substitute this back into our equation, what we end up with is y equals 0.312. Now, because this is 0, x minus 0 is the same as x, so that's going to be x squared plus 53, and that is going to be true for the range 0 up until x equals 35. So our second curve Our second curve is upside down. It's got a maximum point here, and it also passes through this point. So our second curve, curve 2, our second curve, so curve 2 has a vertex, so its turning point is at the top, because if you remember back to GCSE, a vertex is basically a corner. So the corner, or where it changes direction, is that point. So our vertex, so curve 2, the vertex is at 77 and 77,801, and the crossing point, so the point where it crossed with the previous one, is going to be exactly the same. So in exactly the same way, we're going to use the completed square form. So y equals ax minus p squared plus q. And we're going to substitute in for our vertex. So we get y equals ax minus 77 squared plus 801. So the only thing actually we now need to find out is what A is, and we can do that by substituting in the other point. So at the other point we have 435 is equal to A brackets 35 minus 77 all squared plus 801. Now, a thing that's possibly useful to notice is that your second parabola is upside down, so you're expecting it to be negative. So, delete all, yes. Okay, so we've got our 435, so we're going to have to take off 801 from both sides, and that will give us a minus 366, and then our A was multiplied by 53 minus 77 squared, which is 1764. So A is going to be minus 366 divided by 1764. That's not true, because that's just not true. So we have minus 366 divided by 1764, and that gives us a value for A of minus 0.207. 7. So we can then substitute that back into our original equation. So we end up with y equals minus 0.207 brackets x minus 77 squared plus 801. Now, the range for this one is a little bit different. It starts where the other one finishes, but the range on this one stops. This one, we get to our maximum point here, and after that point, our graph would come back down again, which, given that our axis is the number of people who are dead, that would mean that the number of people who are dead is falling. So this section here would be people coming back to life. So this bit can't exist. So we can only do percentage error or a model up to this 77, we cannot go past it. Otherwise, what we're basically modelling is bringing people back to life. So our range here is going to go up to 77. So bear in mind when you do the percentage error, that the percentage error for the first one, where the rate of death is increasing, is going to be between 0 and 35, and the bit where the rate of death is decreasing is going to be from 35 to 77 and doesn't go any further.